Hi everyone. I've been looking forward to doing this video because we finally get to see what the count is doing in these calculations. In previous videos, we've looked at units, we've looked at prefix multipliers. In the video directly preceding this one, we discussed significant figures. And now we're going to apply those rules to calculations. Here we have subtraction and here we have division. If you've seen my previous videos, you know that I like to use color, and in this video I'll also explain why or what these pink underlines mean and what this green dotted line means. Why don't we just jump into our first set of operations or first set of calculations. And the first set of calculations, we're going to discuss multiplication and division. Multiplication and division. And the phrase that I want us to memorize is go with fewest sig figs. What does that mean? Let's say we have a problem that says we multiply 1.052 times 12.504 times 0.53 equals. Before we take a look at the number sig figs for each of these values, why don't we just simply punch these numbers in our calculator and jot down the answer that's has more significant figures that are necessary. So we could think of it as maybe the unrounded form. 1.052 times 12.504 times 0.53. Unrounded, we're not going to write all those digits, but we'll go pretty far. 6 point. Did I type this in? Oh, did I forget a number? Give me 1 second. I'm looking at my notes and I got a different number than I expected. 1.052 times 12.504 times 0.53. Okay, I think that's what I got. 97173, and I'll stop there. Unrounded. Based on this rule, multiplication and division, we're going to round this to the same sig figs as the number that has the fewest sig figs. This one has 4. This one has 5. And this one has only 2. So how do we round this? Oh, this is interesting. We're going to have to round to the ones place and to have only 2 significant figures because we are basing it off of the fewest number of sig figs in our collection of numbers. Let me put here round to proper sig figs. 6.97. That 7 tells me to round this up to 0, and then that will make this 7. The final answer is 7.0, 2 sig figs, matching the number of sig figs in the value that has the lowest number of sig figs. Okay, a little bit tricky because this digit changes as well because when we round this up, this gets rounded to 7. Easy enough. That's multiplication and division. Let's do subtraction and addition. Plus and minus. What's the phrase that we want to memorize there? It's not going to be based on the number that has the fewest number of sig figs. It's going to be based on what's called the fewest decimal places. How far does a number go to the right? And this is where my notation that you see on the cover comes into play. If I have to add a set of numbers, 2.345 plus 0.07 plus 2.9975. As practice, let's figure out the number sig figs for each of these. Actually, let's not, because I don't want in your notes for them to be cluttered, because the number of sig figs is not important like it was in the multiplication and division rule. The way that I'm asking my students to treat this is you want to line up the decimal and put these numbers vertically. So you're going to rewrite this. 2, and I usually leave a bit of space for that green dotted line that you saw on the cover slide. 2.345. Another decimal, where's that? 0.07. And here we have 2.9975. The pink underline represents to me the last significant figure. There, there, and there. And your answer is going to be based on the number that has the fewest decimal places, or the number that goes least to the right. So that's this value here, 0.07. It stops at the 100th place. All the other numbers also have a digit in the 100th place. So all numbers have digit in 100th place. Your answer should go to the 100th place as well. We're doing addition. Again, just like we did for multiplication and division, you punch in the numbers in the calculator, and I like to write out the number that's been unrounded. And then I round to the proper number of sig figs, and I circle the answer. 2.345 plus 0.07 plus 2.9975. I get a 5 here. 0.4125. And yes, that's on the calculator, that's an exact number because that's the same as 2.4125000000. But I don't need to go that far because my dotted line says I should stop right here. So my rounding again goes to the 100th place because all the values have a digit, significant digit, in the 100th place. These three. The rounding gives me 5.41. We don't have to round up. And circle your answer for sure. Now ultimately, yes, this has 3 sig figs, but you notice that I never counted sig figs. So that's another thing to remember. We don't count, like literally count 1, 2, 3. We don't count the number of sig figs in addition and subtraction operations. Now, let's go back to the cover slide and apply these rules, because what do we do on the cover slide? There's actually two operations. See, the two operations are, we have a minus, and here we have a division. So we're using these two rules, the fewest sig figs and the fewest decimal places. Let me just jot down this real quick. Where did this calculation come from, actually? This came from a lab where we're measuring the density, or we're calculating the density. Okay. The answer is ultimately going to be 1.2 grams per milliliter. But let's work this out together. We'll start a new page also. This is an example problem. And let's say we have a piece of metal, or a chunk of metal, that's 8.83 grams. I'm using the same numbers as the cover slide. We're going to get the volume by water displacement. The initial water level is 8.44 milliliters. And then the final, after you put this into the water, due to the limitations of the glassware, I'm going to the 10th place, and it goes to 16.1 milliliters. The question is, what is the density? Okay, before we get to those rules, fewest number of sig figs for multiplication, division, fewest decimal places for addition and subtraction, we have to be able to interpret the problem. And when they ask for density, that's mass divided by volume. And since mass is given in grams and volume in milliliters, we'll aim for a value or an answer that has grams per milliliter. So I like to jot down the units that I want as my final answer with a question mark, just to help me keep focus. The calculations for this is grams over milliliters. 8.83 grams divided by the volume. Now the volume is the difference between the final reading and the initial reading. I know it's a little strange that the initial reading is more precise or has more certainty, but that's still possible. I put that amount in a graduate cylinder, and then when I plop this metal in, my graduate cylinder has some limitations, and I could only read from to 16.1. So you take the difference, and that's the volume of the chunk of metal, 16.1 milliliters minus 8.44 milliliters. So literally, how would you do this without being worried about significant figures? You would just do this on your calculator. You would do this operation first. 16.1 minus 8.44. And I have a number saved in my calculator. That's the volume. Okay, it's saved in the calculator, so all I need to do is start my new operation, 8.83 divided by that saved answer. And let me write the answer without rounding too much. So you want to write your answer beyond what you feel it would be the number sig figs. Probably the number sig figs in the final answer will be maybe 3, maybe 2, depending on how the decimals work out. So I'm going to go beyond that. This is the calculator answer. Again, when you think about sig figs, reporting an answer like this, you're implying that you know for certain that this digit here is 4. Okay, based on the calculations. But that's not that's not good because none of my digits that are used to make this calculation are inserted into that decimal place. So we're going to use the rules and figure out how many digits I really do need. Let's do the addition and subtraction first. Addition, subtraction, and again, that's the, what do I have? The fewest decimal places. And I'm underlining, and I'm putting a green dotted line. 6, leave some space for my green dotted line, minus 8.44. The last significant figure here is in the 10th place, and here it's in the 100th place. So both digits, both values, have a significant figure in the 10th place, but this one does not have a significant figure in the 100th place. So we can't go to the 100th place for our answer, for our to determine how many sig figs our answer has. I'll show you why that's important, an important distinction. Because what I'm going to do is I am going to literally write the calculator answer first. 16.1 minus 8.44. 7.66. 7.66. And this is where some students get a little bit tripped up. When I did this calculation here with the calculator, you notice that I didn't round after I did this calculation. I took 8.83 divided by 7.66. Because another thing you want to remember is you don't round until the very end. Don't round till the very end. With enough calculations and operations, if you keep rounding after every single operation, or if you round multiple times, you're going to round yourself into some very significant error, and you'll be quite far potentially from the actual value. So what do I do for this? I'm going to use the whole number 7.66, but I'm going to remind myself that the last significant digit for this number is actually this middle 6, based on the green dotted line. Because now when I do the division part, even though I'm using 3 digits for the denominator, I will recall that really only 2 digits are significant. 2 digits are significant. Why is that important? Because when you do division, right, so this first part is addition, subtraction rule. Here I have multiplication or division rule. Okay, it's based on the number that has the fewest number of sig figs. I know I have 3 digits here, but I got to remember that this is only 2 sig figs. And this number here is 3. And because for multiplication and division you go by the number with the fewest number of sig figs, your final answer actually has to have only 2, even though I see 3 digits for each value. It may not have mattered whether I have this number or not. I think it would matter because I would get a different calculator answer if I had left this off, right? If I have left that off. So again, don't round until the very end. 8.83 divided by 7.66. And without rounding to the number sig figs, I have that initial number that I wrote up here. Okay. And now let's round. But you're going to round to 2 sig figs. That's the winner, or what we're going to base our final answer on. The fewest number of significant figures when we do a multiplication or division problem. 2 sig figs, 1.2. So that 1 gets rounded up to 2. And now, since this is my final answer that I want the grader to see, and I have a little reminder here that those are the units I want, and I double check, and those are the units I get, make sure you don't lose any points by forgetting the units. 1.2 grams per milliliter. Okay. So when you have a combination of subtraction, addition with multiplication, division, do it in parts. Don't round until the very end, but always keep track of how many sig figs your answer for the addition or subtraction has. Okay, because you're going to carry that full number into the next calculation, but the sig figs is now 2, not 3. A little bit of practice and this will become automatic. The other thing is, before I leave this video, is that now that number 1.2 makes reasonable sense. That's the certainty. I'm certain that it's 1.2. I'm not certain that it's 1.15274. Okay, so there is error in the 100th place. So that, again, this reflects the certainty of the initial measurements.